Section 8.3 is on polar coordinates. Now normally we plot points in the rectangular, or sometimes it's called the Cartesian coordinate system. This is just our traditional x and y. So x tells you like how far left or how far right to go, and y tells you how far up or how far down you go, and then you plot your point. So that's really the default system that we use for everything. But there is another system, and that's called the polar system, or the polar coordinate system. And this is just an alternate way to plot points. And this uses an r and a theta. The r is the radius, or how far it is from the origin, or what's sometimes called the pole. And theta tells you the angle from the polar axis. So the reason why we have this is because in calculus, certain functions are much easier to deal with in a polar system. So we could do the math in the normal rectangular system and it could take a really long time, or we could take the time to first convert it to polar, and then sometimes the calculus goes very quickly. So this really comes into play in calculus, and that's why we're looking at it here. So it says plot the point that has the given polar coordinates, and for these systems each angle is worth 15 degrees. So our process is really to find the line first with the angle. And then find the circle. So with number 1, it's 30 degrees, which is right here. And then the radius is 4. So I want to use this line, but I want to do 4 circles towards the 30 degrees. So 1, 2, 3, 4 would be right here. So it's that many circles or radiuses or radii towards the angle that you declare. With number 2, 60 degrees would be right here. And when it's negative, you actually want to do circles away from the angle that you declared, but on the same line. And sometimes this can be kind of difficult to go backwards because it's really easy to get lost on what line you're at when you're going in the opposite direction. So if you want to use like a ruler or something, then that could be a good idea. So I know that that is my line. And if you don't use a ruler, it can be kind of tricky sometimes to see it. And I want to go 2 circles, starting at the origin, I want to go 2 circles away from that. So it's going to be right here. But it's still on that same line. And then I'm going to erase my line here. And there we go. And I'll erase that. 60 degrees. So if it's negative, you start at the origin and you go 2 radiuses away from it. Positive, you went here 4 radiuses towards the angle. With number 3, pi over 2, so sometimes it can be in radians, sometimes it can be in degrees. Either way works. Pi over 2 or 90 degrees is up there, and 3, and it's a negative 3, so it's away. I don't have usually a problem with like the straight up and down or left and right ones, but again, if you want to put a ruler here to see that that really is the 1, you can, but usually it's only on the diagonal ones that I have to put the ruler. So negative 3 is going to be 1, 2, 3 away from the angle that I declared. If this were a positive 3, then my point would be plotted right here. But it's negative, so it's over there.